Greetings, dear friends. We are happy to welcome you on the program Expert's Opinion on Creative Society channel. And today with us, Dr. Don Easterbrook, professor of geology at Western Washington University. He conducted research on ancient and recent global climate change in Western North America, New Zealand, Argentina, and various parts of the world. My name is Irene. Today is with me Ivan, and I give you the floor, Ivan.
We would like to tell you that recently we had a conference which was actually aired in over 180 countries. It was simultaneously translated into 100 languages. Millions of people watched it, and it was done by volunteers, and also there were lots of scientists present, which we are staying in touch with right now. And this interview is part of this effort of bringing knowledge up to the people and telling the truth about what is really going on in the world. I believe you have a presentation ready for us. What would you like to show us today?
Hello, my name is Don Easterbrook. It's essentially my background and how I am doing this. I'm a geologist, PhD in geology, and my specialization is the study of glaciers. And glaciers are like Earth's thermometers. When the climate is warm, glaciers retreat. When climate is cold, glaciers advance. So by studying the advance and retreat of glaciers, we can tell what the climate was doing in the past. And that gives us then a good basis for knowing what the history of climate change has actually been. So I've been studying glaciers for 60 years, and especially looking at the climate changes that are shown by those glaciers. And I have something like 200 publications in journals and probably more than a dozen books written about climate change and some of the things that are important in producing climate change. So that's my background. The problem is that the information that's going out on all the news media is badly in error and is highly biased. And so not many people know the true facts of what's going on with the climate. And the truth is that the climate is always changing, and it's changed many times over thousands of years, and without any effect of CO2. We can only blame CO2 cause of any climate change after World War II, because that's when the atmospheric carbon dioxide began to rise. Anything before that cannot have been a cause of human-induced atmospheric carbon. So looking back at the geologic record, what we can see is that there have been many, many climate changes, contrary to what we call the alarmists are saying. They have been claiming climate emergencies for 40 years now, and none of the things that they have predicted have come true. The climate is always changing, and if you can see the slide on the screen, this is a diagram that shows temperature from an ice core in Antarctica, and the graph is of temperature, where the red ones, red spikes, are warm periods, and the blue ones are cold periods. And what we can see is that climate has been changing for 800,000 years without any inducement from carbon dioxide. Another thing is that there's a bad misconception that for some reason global warming is bad. And the truth is, warming is a good thing, not a bad thing. Crops thrived during a medieval warm period, about 900 to 1300 AD. The warmer climates allowed abundant growth of grain and cereals for food. And so with no food shortages, people had much more time to turn their attention to other things, So it was a time of great advancement in terms of the human populations. The civilizations have always thrived during warm periods and have done badly during cold periods. So global warming is a good thing, not a bad thing. Atmospheric carbon dioxide didn't begin to rise significantly until after World War II, when we had a lot of industry putting carbon dioxide in the atmosphere. So no climate change before 1945 can have been caused by the rising of CO2, because before that it was fairly constant. So we're talking about the so-called global warming emergency. We're talking about only the time after 1945. Anything before that can have nothing to do with CO2. There's no correlation at all between carbon dioxide and global warming. The graph you see on the screen shows a curve with some colors. The temperature from 1920 to 1945 or so is shown here in red because it was very warm. And then we had a period of global cooling from about 1945 to 1980, during a time when CO2 was rising rapidly. And so there's no correlation here at all. During this period from 1945 to about 1980, temperatures dropped to the point that there was great fear that we were entering a new ice age. And yet this was a time when the CO2 was going up very rapidly. We know that CO2 always follows global warming. And so if it follows global warming, it can't be the cause of the warming. Simple logic there. And so this is a graph that shows the temperature from an ice core in, this one is in Antarctica, I think. And the red curve here is temperature. There's always a lag between the CO2 and the temperature. In other words, CO2 always follows the warming and therefore can't be the cause of it. Virtually all of the past 10,000 years has been about 3 to 5 degrees Fahrenheit warmer than at present. This is a graph that shows temperature. The red temperature here is warmer than present, and the blue is cooler than present. So from 10,000 years until about 1,500 years ago, the temperature was 3 to 5 degrees warmer than at present, with no ill effects. It didn't cause any harm at all. And then we dropped into a little ice age. Another question is the amount of carbon dioxide in the atmosphere. Carbon dioxide is a trace element. There's very, very little of it. There's only 41 thousandths percent CO2 in the atmosphere. Very little of it. And so it has, it's asking a lot to have it cause these great catastrophes. The CO2 rose by only 8 1/1000ths to 1% from 1958 to 2014. That small a rise could not possibly cause any kind of climate change. It's close to nothing. You double nothing, you still have nothing. So such a small amount of CO2 is not capable of causing significant global warming. Global temperature has risen only 0.1% per decade over the past 40 years. No warming occurred during this time, in some periods up to 20 years. There's been no significant global warming in the past 10 years. And yet we hear cries of some kind of climate emergency, which is certainly not the case with only 0.1% per decade. That's right at the limit of the amount that you can measure. And so the point here is that the amount of temperature rise over the period since, 40 years ago, amount of temperature rise has been practically nothing. And let's see where we are. Here we are. Most of the catastrophic global warming hyperbole is based on computer models. And so we've had enough time now since the computer model did their predicting and what actually happened to compare the two. If the models are correct, then if we look back, the model's temperature should correspond to the actual temperature, and it doesn't. It's not even close. It's way, way off. So in this graph right here, we're looking at temperature. Temperature rises in this direction. And the computer models of all, these are all individual models, and all of the models, the sum is this black line right here, which shows a rise in temperature from about 0 to about a little over 1 degree. The actual measured temperature during the time span back here is much lower, which means that the models are worthless. The models do not have an accurate look at what's going on with the temperature in the world. So the point here is that predictions based on computer models are totally unusable. Will Happer is a physicist of world stature, and he and some of his colleagues have shown that all the available wave bands in CO2 that are capable of absorbing heat are already saturated and cannot cause further warming. What this means is that carbon dioxide has about 5 wavelengths in which it can absorb infrared, that is heat. And once those are filled, it's like a sponge. If you try to soak up water on a countertop with a dry sponge, it soaks it up. If you try to soak it up with a wet sponge, it won't, because it's already saturated. And the same is true with carbon dioxide in the atmosphere. All of the wave bands in carbon dioxide that are capable of absorbing heat are already saturated, and it can't take in any more heat, and so it cannot cause any further global warming. And this is really significant, because it means that CO2 cannot be the cause of global warming. Number 11, the Antarctic ice sheet is not melting. In fact, Antarctica is getting colder. One of the things we also need to be aware of is that NOAA and NASA tamper with the measured climate data to make cooling appear to be warming. The 1930s were the warmest decade of the century, no doubt about it. And what the NOAA and NASA people have done is they've subtracted temperatures from the warm periods of the 1930s to make them appear cooler. And this blue color here is the amount of cooling that the NOAA and NASA have imposed on the actual measured temperature. They've made all the temperatures in the 1930s cooler, and there's no basis for that. If anything, it should be the opposite. And they have made recent temperatures warmer. That's what the red temperature is here. And the red temperature is exacerbated by what's called the urban heat effect. The cities have a lot of concrete and they retain heat, and so cities are notably warmer than countries. And many of the measuring places now are in this system. So the problem here is that this tampering, this subtracting temperature from warm temperatures in the 1930s is totally unjustified. So what's it all about then? And this is a chief UN official who admits that global warming is political, not scientific. And what she is saying here is that the question about climate change is not a scientific question, it's a political question. And they are hoping to use fear of climate change in order to get a government run by the UN and with no input from other countries. You give up your sovereignty. So this is what's behind it. It's a hoax. And the hoax is that the global warming issue are political. They're not scientific. So what is the situation with the climate then? What is causing the climate to change? And I made a study of all of the ice cores in Antarctica and in Greenland to find out what was going on. And it's very apparent that the sun has a big impact on what's going on. And in particular, sunspots. Sunspots are spots on the surface of the sun. Here's a close-up of one of them that are places where the solar magnetic field is disturbed, and it makes then these sorts of things. These are sunspots. They're depressions locally, and there are places where there's intense magnetic activity, and the temperature is lower due to the reduction of heat from outer interior by these strong magnetic fields. So here's what the sunspots look like. They come in pairs, and here's one that makes a big arch-like feature. So what is the effect of the sun's magnetic field on the climate of the Earth? And it is profound. In this diagram, this is the sun, and the sun has a strong magnetic field, and it varies. Sometimes it's strong, sometimes it's weak. When a solar magnetic field is weak, then it doesn't intercept cosmic rays that are coming to the Earth very well. And when it's strong, it acts as a shield to block cosmic rays from coming to the Earth. Well, what difference should this make? What happens is that cosmic radiation is always high during times of global cooling, and sunspots are always low. So what this means is that the sunspots are telling us that the sun's magnetic field, when it's low, allows a lot more incoming radiation. The incoming radiation, cosmic rays in the atmosphere, hit atoms up in the upper atmosphere, and they produce ions, and these produce isotopes. Isotope is a slightly different configuration of an atom, and in particular, beryllium is produced by the incoming cosmic rays of the atmosphere. So if we can measure the amount of beryllium in the atmosphere in the past, we can tell what the solar magnetic field looked like. And the most useful in this is beryllium. This is beryllium 10, and it falls, is produced in the upper atmosphere by incoming radiation, and it comes out in snow crystals that fall on glaciers and is preserved. So in other words, there is a preservation of the beryllium content of the atmosphere throughout the length of time that the ice was accumulating. And in the case of the Antarctic ice cap, these go back about 800,000 years. So we can tell what's going on with the solar magnetic field by looking at the amount of beryllium that has been trapped in the ice as a result of that radiation. And so why does this matter? Because there's a close correlation between cosmic rays, incoming radiation, and low cloud cover. So here's low cloud cover, that's the blue, and cosmic ray decrease, and look how closely they match. And the same thing is true with temperature. There's a strong correlation between cosmic ray counts and global temperature. So it looks as though the cosmic rays are causing the temperature to vary. So what this allows us to do then is to measure the amount of beryllium-10 in ice cores to tell us what the magnetic field of the sun was doing in the geologic past. So and this can be measured, and has been measured, many measurements from ice cores. And what we find is that beryllium is highest during cold periods. The biggest one was called the Maunder from about 1650 to 1700. Another called the Dalton from about 1790 to 1820. And finally, a cool period from 1880 to 1915. All of these cold periods were characterized by high amounts of beryllium. And that means a lot of incoming radiation. there's a direct correlation between cold temperatures and production of beryllium, which is the measure of incoming radiation. The temperature is shown here in red, and the beryllium content in yellow. So beryllium follows the temperature very closely. And what we find is that the cosmic ray intensities are greater when the sunspot numbers are low, meaning the sun's magnetic field is low. And you see the inverse correlation here. And as solar activity goes up, cosmic rays go up, then the temperature also follows. Here's a chart that shows the variation in cosmic rays, and here's a corresponding temperature. So when cosmic rays are high, then we have a lot of cloud cover, and we get cooling. So the geologic evidence of solar influence tells us that the amount of solar irradiance, amount of sunspot, or amount of temperature change from the sun is very low, but it shows what's happening to the sun's magnetic field. So here's a summary of the conclusions that, let me go back one. Fluctuations in the sun's magnetic field causes changes in cosmic radiation, and this is measured by the production rate of beryllium-10, which induces condensation of water vapor, produces clouds, and that causes cooling. And then the opposite is also true. So here's a graphic showing that when you have low solar magnetic strength, we get few sunspots, and we get a lot more cosmic rays coming into the Earth. This increases cloud formation and causes more energy to be reflected in space. Solar energy is reflected by the cloud cover, and that gives us then a cooler climate. So what happens then is the cosmic radiation comes in, and it causes interaction in the upper atmosphere, and this produces more cloud cover. So we're now in a situation called advanced solar minimum, where the sun's magnetic field is low. And so in the next 5 or 10 years, we'll see what happens to the climate during this period. And right now it's cooling. And so nature very soon is going to tell us whether we're right or wrong. We'll know in probably about the next 10 years or so. So that's a summary of some conclusions that are verified, and you can verify them yourself actually if you choose to. So that's the end of the slides. Do you have questions?
Yes, thank you so much for this amazing presentation. We would like to ask you a question. What is, on your opinion, the strongest evidence observed that global warming is not caused by CO2, and what is the biggest data falsification you observe for current changes on the planet? So maybe you could briefly summarize what you showed on your presentation.
The whole idea of global warming goes back about 40 years and comes from the United Nations, from a committee that was set up to study the effects of carbon dioxide. There's no doubt that carbon dioxide is a greenhouse gas, meaning that it can't absorb heat. But it absorbs so little heat, almost none, because there's so little of it in the atmosphere. Very little change, only 0.008 of 1% change in the composition of the atmosphere. And so there's very little effect that carbon dioxide can possibly have. To summarize, the effect of CO2 is essentially a hoax, and is made for political purposes, not for scientific purposes. And we know that because the effect of CO2 is so minute. There's so little of it in the atmosphere. During the time of so-called global warming, the carbon dioxide in the atmosphere increased only by 0.008 of 1%. which is about as close to nothing as you can get. You can even double nothing and you don't get anything. And we also know from a study of the saturation of the wave bands in CO2 that absorb heat, that those in the atmosphere now are fully saturated, and therefore they can't take in any more heat, and therefore they cannot cause any more global warming. So the bottom line here is that CO2 is not the cause of significant global warming.
Thank you very much. From your presentation, as far as I understood, correct me if I'm wrong, but we're not in the global warming trend. We're on the verge of cooling, right? Because we have less sunspots, and we do see more cosmic rays penetrating the Earth's atmosphere. So there should be more clouds. So, am I correct? Are we on the verge of global cooling?
Yes, we are. We've just entered a phase of the sun, just called a grand solar minimum. Means minimum amount of radiation. And therefore, the prediction is that we should be entering a cooling phase, not a warming phase at all. And that seems to be happening. There's been no significant warming in the past 10 years, despite all the clamor about the climate emergency. There's been no significant global warming for the past 10 years. And in the past, before that, there were periods of 20 years when there was no global warming at all, despite all the clamor of climate emergency. So it's pretty clear that the temperature fluctuations go up and down naturally. And we have entered now what's called a solar, grand solar minimum, in which we would expect to see global cooling, fewer sunspots and a lower magnetic field, and therefore more radiation, therefore more cloud cover. And that appears to be happening.
Okay, wonderful. Have you noticed, let's put aside the global warming and anthropogenic factor, because we don't believe in CO2 ourselves, but what we are really interested in is what is really going on with the climate in terms of what is changing in space. Like you said, we have, it's a solar minimum at present. Have you noticed an increase in solar radiation, or any other radiation, let's say gamma rays for that matter? And B, what have you noticed since you were looking at the ice cores? Is it a cyclical trend? Are we in the period of certain change which happened before in any cycles you've noticed?
Yes, this has happened many times before, and we have a good geologic record of it from the ice cores. We can determine ancient temperatures with a certain amount of accuracy going back 800,000 years. So we have a good record of what's gone on in the past. And it appears now that we have just entered the grand solar minimum, and that we should be headed for cooler temperatures. So if we look at the temperatures to see if that's happening, the answer is yes. And if we look at the amount of radiation that's coming in, we find that it is in fact increasing as it should be with the lower solar magnetic field. So it looks like we're headed for cooling.
Could you speak a little? Could you tell us a little more about cosmic rays, how it affects us? I mean, we understand we're expecting cooling. We're just interested in what is going on, except for solar minimum. Do we have, can you list of types of radiations and how do they affect the climate?
Well, the principal effect on climate is the production of cloud cover, which reflects solar energy, and therefore has a tendency to cool the Earth. So what's happening now is that the solar magnetic field is decreasing, and the net effect of that is to produce more clouds on the Earth because there is more radiation coming in because of the low solar magnetic field, and the clouds that form then reflect the sunlight, reflect the energy, and cause the global climate to cool. And that indeed is what appears to be happening right now. And this cycle will go on for a couple of decades at least, maybe 20 or 30 years. So the prediction based on what the sun is doing right now is that we should be in for about 20 or 30 years of global cooling.
How cool do you think it's going to get since we have a global cooling?
It's not going to be large in terms of temperature on a thermometer, and probably the most likely it's going to be in a range of a degree or two, which doesn't sound like much, but it is enough to cause an appreciable change in the atmosphere and to come across as either cooling or warming trend. So it's not going to be large. It's going to be in terms of the thermometer. It's going to be a degree or two, something like that. But it will cause significant changes.
Okay, and we would like also to ask about Heinrich events. What can be caused for the strong changes of the climate that can be changed up to 10 degrees and then go back? And all this happens in a short period of time, especially in huge jump in Younger Dryas.
Yeah, the Younger Dryas was an amazing period. It happened right at the close of the last ice age, which occurred roughly 11, 12,000 years ago. And what happened was that the Earth had been in an ice age, and it warmed up abruptly, very abruptly, over a matter of a century or less, rising many degrees. And then all of a sudden it cooled off again after it had originally essentially went from a glacial phase to a non-glacial phase. And then all of a sudden it dipped back into a glacial phase. And this is called the Younger Dryas. Occurs roughly 10,000, 12,000 years ago, something like that. And during that time, the climate cooled significantly and glaciers began to advance again. Not the big ice sheets, but smaller glaciers felt the effect of this. And it's a global effect that indicates that the glaciers all over the world were responding to a truly global climate change. And so the question then becomes, what caused the Younger Dryas? And the cause of the Younger Dryas is apparently the result of a change in the solar magnetic field. During the end of the last ice age, there were quite a number of very abrupt climate changes, like going from glacial to non-glacial in a matter of a century. And that's a big jump. And that's what happened with the Younger Dryas. But there are also some other ones. And the interesting thing about these is that for each of these short-term abrupt climatic changes, the beryllium content in the ice cores changes exactly at the same time. So there's a direct connection between these sharp climate changes at the end of the last ice age and the amount of beryllium that's produced in the upper atmosphere. Well, we know that the production of beryllium in the upper atmosphere is caused by the amount of solar radiation that we're getting. And so what we can infer from this then is that the reason for these very abrupt climatic changes is a very abrupt change in the solar magnetic field. The correspondence is just absolutely amazing. I nearly fell off my chair when I saw it, that in a matter of less than a century, the climate changed and the beryllium changed right along with it. And so the beryllium seems to be an indicator of what's going on with incoming radiation. And that is what's causing a change in the cloud cover. And that's what's causing the climate to warm and cool.
Very interesting. Is there an increase in beryllium production today?
Oh, yes. Beryllium is always being produced in the upper atmosphere. Incoming radiation strikes oxygen atoms and called a spallation atomic reaction, and it converts it into beryllium. So the simplicity of it is that the more radiation you have, the more beryllium is produced by interactions with the atmosphere. This means that we can use beryllium as a measure of the amount of incoming radiation. And then when we compare this to climate changes, we find that there's a one-to-one correspondence between climate change and changes in the beryllium content of the upper atmosphere, which means a corresponding change in the strength of the solar magnetic field.
By the way, like since we talk about magnetic field, the Earth's magnetic field is weakening, and that's one point. And the other point is that North Pole is shifting, and it's shifting rapidly. The pace of it is increasing. Is it correlates with lowering of solar magnetic field? Have you seen it before on ice core records?
No, the Earth's magnetic field fluctuates, but it's independent of the solar magnetic field. It does its own thing, and you're right. It has been changing slowly over a period of years, and so we have to consider the Earth's magnetic field as well as the solar magnetic field when we're talking about cloud cover. And so far, it appears that the driving force is a solar magnetic fluctuation, not the global change.
And as we observe accelerating moving of the magnetic pole, did you observe or have any information that it was happening in the past as well?
Oh, it happens all the time. The magnetic field of the Earth is not coincident with the rotational axis. It wanders. The magnetic field wanders around, and so if you go to any given area and you want to, set your compass, you have to account for the change in the magnetic field. The importance of this, I think, is that even though the Earth's magnetic field does change, and it appears to be now accelerating a little bit, and we don't have a really good idea what's happening, but it's normal for the Earth's magnetic pole to wander around the rotational axis. It doesn't stay in one place, and so when you set your compass, you have to make an adjustment for the deviation between the magnetic field and the axial pole.
Have you seen any other effects on Earth from changes in the solar activity, like weakening magnetic field? You're saying that is it only radiation? Does it correlate with earthquake activity or maybe volcanic eruptions? Anything like that?
Yeah, there seems to be a good correlation between the global climate and incoming radiation. That is, during historic time, during measured times, they seem to go up and down together.
Have you? Lately we find lots of research talking about geothermal flux increasing on the Antarctica, also on the Greenland, and many other places in the middle of the ocean, and that it seems to be causing the melting of the glaciers, as well as warming up the oceans. Have you looked into that? Do you agree with the statement? What do you think about it?
Oh, I've looked at it in great detail, especially in Antarctica. Antarctica is a very unique place. It has the greatest concentration of ice of anything in the world, and therefore, if that ice were to melt, it would cause a significant change in sea level. And the data shows conclusively that Antarctica is not warming, Antarctica is cooling. We have new data that just came out a couple of weeks ago that confirms that original effect. And we know the temperature in Antarctica, both from satellite temperature measurements and from ground measurements at two stations at the South Pole. The amount of melting that's going on in Antarctica is due to geothermal warming under the ice. This is heat coming up from below. It's a volcanic area. The heat coming up from below is melting some of the Thwaites Glacier and one other glacier, the West Antarctic ice cap. The major ice mass, 95% of the ice mass in Antarctica, is in the east Antarctic ice sheet. And that's getting colder, not warmer. And it turns out that the area where there's some melting under the West Antarctic ice sheet is an area of volcanic activity. And so the heat that's doing some melting at the bottom of the glacier is coming from underneath, and it has a volcanic source.
Also, we would like to ask you about Holocene optimum. What do you know about that, and how high were temperatures?
The climate at the end of the last ice age is really very interesting because it changed very rapidly. Right at the end of the last ice age, we would go from a glacial climate to an interglacial climate in less than 100 years. Very, very dramatic and repeated abrupt climate changes. So we know that these changes can occur rapidly. Then at about roughly 10,000 years ago, we had a big warming. We came out of the glacial period of the Younger Dryas to modern Holocene climate. And the Holocene climate was about 3 to 5 degrees warmer than today for almost all of its 10,000 year history. From 10,000 years ago to 1,500 years ago, the climate, or I should say the global temperatures, were 3 to 5 degrees warmer than they are now, with no apparent adverse effects. So the climatic optimum is a period in the early part of the Holocene. Holocene is the last 10,000 years. So in a period somewhere around 8,000 years ago, plus or minus a bit, there was a period of what's been called the global optimum, during which time temperatures appear to have been warmer than they were later on in the Holocene. It's a well-documented thing, but it was also punctuated by a few periods of colder climate. The climate didn't stay constant at all. It was always going up and down.
Next question in regards to what should humanity do? Since, well, just like you said, CO2 is a political issue, and it's related to fuel markets, whatever the geopolitics and the rest. But since you're saying that we're expecting the cooling in recent years, how should we prepare instead of cutting down on fuel consumption and going after green technologies? What do you think? How should we adjust to what's coming up?
And a good point there is that we can't control climate. We can only adjust to it. And the adjustments that you need to make for a cooler climate is that you can expect the growing season to be shorter in northerly latitudes, and that the maximum growing period will shift southward. So we could expect the grain belts, perhaps in the central U.S., to shift southward somewhat to find the optimum growing conditions. It's difficult to predict how cold it's going to get, so we don't know how much we need to adjust to. In terms of actual temperature, as I said, it's not going to be a lot, maybe a degree or two at most, but that has significant effects on the growing season and on food production. So in a cooling climate, what do we need to do to prepare for it? We need to be prepared to increase energy consumption, because as it gets colder, there is a corresponding increase in the amount of energy demanded for heating, for all sorts of things. And the same is true with food production. We need to look at the effect that the cooling climate will have on food production. And generally, the effect of cooling on food production is not good. During the Maunder period of terrible cooling in Europe, millions of people died from starvation and disease because they couldn't grow grain. The grain crops kept failing. And so now we have a much better idea of how to do things. And so we grow a lot more grain, and the effect will be less. But the principal areas that might be affected, Africa in particular, but also North America and Europe, will certainly be affected to some extent by this cooling.
Just like you said, the current climate situation or CO2 policies is more political rather than scientific. Given that fact, we could honestly say that science has been politicized and doesn't particularly serve its purpose of scientific research and serving to the people. What do you think should be done in modern society in order to make sure that science serves its purpose and is serving the people?
Yeah, unfortunately, the climate hoax, as I call it, has had a very bad effect on science because it has politicized science. There is endless amounts of money available for anybody who wants to do research, climate research in science, and to come to the conclusion that it's all CO2 and we're all in for a catastrophe. Anybody who wants to say that sort of thing can get huge amounts of money, millions of dollars for their own research. So there's a bit of corruption going on in the science, and the politicization of science, I think, has deeply damaged the credibility of science as a field. The amount of just pure rhetoric that has gone on with no scientific basis has had a bad effect on science. So the bottom line is that it's affected the credibility of science, I think, now is less than it was before it became politicized. Well, I think we know the cause of climate change now because of the work that I did with the solar magnetic field. I think proves pretty conclusively that climate change is governed by the solar magnetic field of the sun, and nothing to do with CO2. And I think what needs to be done is to follow that conclusion with more data, find out more about it, and instead of directing all these phony studies on CO2, there should be some funds spent studying the effect of the solar magnetic field on climate.
Thank you so much. Thank you for this interview. And we would like to invite you and invite all the viewers to our international forum. And it's called Global Crisis, We People, We Want to Live. We continue to raise and talk about sharp issues in our society, such as climate change, human trafficking, human slavery, climate refugees, and the most important, that we talk about the ways out. How can humanity find a way to unite and actually together resolve these problems? And we invite everyone to share information about this conference with the people from all over the world. Join watching, and thank you so much for being with us.
You're welcome. I look forward to looking at your results.
No lie lasts forever. Truth always triumphs. Now is the time for the truth. We will give you the facts of historical deception of all of humanity. In the year 1992, a 12-year-old environmental activist, Severn Suzuki.
I am fighting for my future. Losing my future is not like losing an election or a few points on the stock market. I am afraid to go out in the sun now because of the holes in our ozone. I am afraid to breathe the air.
The year 2018, a 16-year-old eco-activist, Greta Thunberg.
How dare you! You have stolen my dreams, my childhood, with your empty words. On my generation, sucking hundreds of billions of tons of your CO2.
Interesting, isn't it? An old song written by the Cooks of Lies has been played again after 27 years. So what is the reason for such ardent performances by young eco-activists? In 1989, the Montreal Protocol was signed. The major scarecrow for people was the ozone holes. This scam destroyed the world's refrigeration industry and allowed billions to be made on this swindle. The ozone holes did not disappear, but the pockets swelled with dollars. In 97, the Kyoto Protocol was adopted. The main problem is the infamous CO2. Greenhouse gases are now a new commodity. So the total climate finance average in 2019-2020 alone amounted to 632 billion US dollars. A new global scam that is profitable for those cooks in the kitchen of lies. These subhumans exploit children, pleading for sympathy. Aren't you sick of it? to slurp down a stinky broth of lies and pay for it with your hard-earned money. The climate fight today is a big, cruel business. We are forced to toil away for food and shelter and to pay for air. The climate attacks and kills us mercilessly. It spares no one and takes no money. Cataclysms are escalating rapidly, and they are becoming stronger and more synchronized. Let's not be silent any longer. It's time for the truth. It is time to act. Let's bring the whole world together